As the last step of this particular visualization, step 9. Step 9, here we are basically we are going to do apply a clean theme and move legend. Themes controlled, background, grids and styling. So we are going to use theme minimal. Theme minimal. So this theme minimal removes heavy backgrounds and gives a clean look. The second thing we are going to do is we are going to change a legend position using theme legend dot position is equal to top. So this is the second change we are going to do here. Moves the legend above the plot. So second thing we are going to do here is one is to set the theme to minimal, that removes the heavy backgrounds and gives the clean look. The second thing is moving the legend to the top. We have this legend at the right side of the graph. Now we would like to move it to the top of the graph. That is what these two things we are going to do here. So why we are moving legend, right? So when the legend is at the top, it is often easier to notice and read, especially during presentations. So it is my assumption and the imagination, in case if you are very much comfortable to keep the legend at the right side of the graph, then it is all left to you. But I would like to move the legend from right side of the graph which we are visualizing to the top side of the graph. According to me, it is my perception that it will give you the better readability to the users. So let me insert the code block here. Again, ggplot data. We have AES. So in the AES, we need to specify what goes on the x-axis is sepal length. The y-axis takes sepal width. And the color we are giving is species, right? So geom underscore right point for making the dot plot or the scatter plot. Alpha we have set it to right 0.3 we had set in the previous step, and size right, size we are setting to 7 or 8, and we will be able to see this particular output. And in the previous step we had also even set the labs, and I'm not going to write the labs again. I'm copying it from the previous step, the labs. So this labs I'm adding it here. The labs I have added. We'll be able to see the title for the graph, the updated title or the label for the x-axis and label for the y-axis, along with the updated title for this particular legend. So the labs 2 time plus plus we had done. So the my graph got updated. Now my task is to set the minimal theme underscore minimal. All right. So you can see the difference between the previous graph. This is what we have. It has a heavy gray color background. Now my graph is updated. Here we can see the background is little bit lighter in color, and the species, that means the legend of the graph is also got updated. It is looking more cleaner than how actually it was previously. One more final step I would like to do is in this theme I need to move legend dot position, I need to set to top. So let me execute this. Now the legend has come to the top. We have got a wider space for the graph. When the graph was when the legend was occupying the right hand side of the graph, the most of the space of the graph was occupied by the legend. Now we have, because we have moved the legend to the top of the graph, we are able to see the actual graph is covering entire width of the visualization or the graph, and the legend has come out to the top, and it is more convenient for the users to use this kind of, or to read this kind of visualization. So like this, we have updated the graph, and finally we have completed all the steps. So let me walk you through the steps what we have completed. Very first step is we have loaded the libraries. The libraries we have used here is ggplot2 and dplyr. Technically, we have not used DPLYR because we have not done anything related to pipeline operator and some data science related stuff. But keeping a DPLYR as a loaded library at the beginning itself will help you to rather loading at the later stages of your analysis and visualization. Keeping the DPLYR loaded is better. And then we had done the loading the required data set is the iris data set. We have taken the copy of iris data set, and after that we had seen the dimension of the data set, and we had seen the first 6 rows of the data set using head of iris. We have seen the last 6 rows of the data set using tail of iris. The structure of data set, that means how many rows are there, how many columns are there, what are the data type of each column, we had seen using structure of data. And we had seen the summary, what are the representative values and the summary statistics of each particular column in the particular data set we had seen. And we had also seen what are the names, the column names of the data set, dim names, that is row names, as well as column names of the data set. Dim, that is how many rows and how many columns in the data set, and different kinds of analysis we had done with the help of the exploratory commands and the function which are available in R programming. So once after doing this, we had moved on to inspecting the categorical variable. As we had already, it was apparent that we had a um, four columns which are numerical and the one column which is the categorical. So we had taken up the categorical column is the species, and we wanted to know how many different types of values are there. And to do that, we had seen the species column separately, and we got to know there are 3 different values are there, but we wanted to count how many times each of these 3 values are repeated. That's why we had taken a help of table that showed us these 3 values of the species column has repeated 3 times, repeated 50 times, that is making 150 rows. That means the distribution of these values are uniform. And then we had also seen what is the type of the species column, because the species, if the species column is the character column, then we could have not used the species column as the categorical variable. We had to convert that character column to the factor column, because here in this data set the species column by inherently it is the factor. We did not do that extra work of converting the character species column to the factor species column, because it is readily available as a factor. So once after seeing all this exploratory thing, we are managed to visualize the data. The x-axis we have mapped to sepal length, and the y-axis we have mapped to the sepal width. And we have done the scatter plot visualization. Here the problem is each dot represent each row, but we are not able to find out which dot is belonging to which category. That is, we have uploaded, we have added the color information along with the x-axis y-axis information. Here we have updated the coloring information also. The each dot has got its own color depending on the species it belongs to. Here you can see the clear color clustering information where the different category of the same flowers are belonging to. And then after that we had done some improvisation on the visualization by decreasing the transparency of the dots and increasing the size of the dots with the help of the size and alpha being given to the geom underscore point. Further, we have added the title of the graph, x-axis title and the y-axis title of the graph. and the title of the legend as well we have updated. Finally, what we had done was we have moved the legend from right to the top, and we have added the minimal theme so as to remove the complicated visualization. The background was cluttery before, it was in the gray color, now it has become the white color, and it is very pleasing to see this kind of visualization. This brings us to the end of the second program. In this second program, we had visualized the iris dataset, which is having three different categories. The numerical information belonging to three different category has been visualized. So here are the couple of discussion questions you can ponder upon, and you can come up with the answer. So very first thing I want you to answer is, do you see clusters of points by species? The second question I would like to ask is, which species appears most rated from others? What happens if you plot petal dot length? This is an interesting question because we have only done for sepal length, sepal width. So what happens when petal length, right? Petal length, petal width. What happens if you plot petal length versus petal width? This is an interesting question you can answer. Only thing you need to update the attribute names in the functions. The last thing is, what changes if you remove alpha? The first thing is there anything is going to change if you remove alpha, or increase, or increase the size attribute, size further? So these are the follow-up questions you can tweak into the code what you have now to see your answer. I presume, I expect this series of videos with respect to program 2 are insightful, and you understood the concept clearly. Thank you all for seeing the videos related to the second program. See you while doing the third program execution. Thank you all.